Today's lesson is volume by cross sections. What I want you to visualize is a loaf of bread. Okay? If I was going to graph my loaf of bread, there's a line here for the length of the bread. It goes that long. And coming out of that rectangle are the slices of bread. Okay? They're squares sticking up in the air. And I'm going to find the area of each one of those squares of bread and add them all together. So I'm basically doing three-dimensional Riemann sums. All right. On the page where you found these blank notes, there's the filled-in notes. There's some excellent pictures there if you need help visualizing what a cross-section looks like. Okay. But a loaf of bread works pretty well. Each one of these slices of bread, I can find the area of it. Side squared, right? And then you add this one to that one to that one to that one, and you add them up. Well, when you accumulate things, it's an integration. All right? So, that's what we're doing. Well, and it ties to our lesson on the area between curves. Okay, so what happens is that I'm going to have my curve going like this, and it intersects with this curve here. I need to find these intersection points to find A and B to integrate. The area between them, that length, is the length of the side of your object coming out of the paper. So if we're doing a loaf of bread again, these would be squares. This square would be about that big. This square would be that big. This one's about that big. So you have little squares, and you can figure out the area by the difference, the top minus bottom, and then you square that distance, right? Because top minus bottom is one of the sides, and you're going to square it. So we're going to come down here to a formula. I'm going to call B is equal to the distance between curves. All right? How about the curves? There you go. So on a square, it's going to be B squared. All right, we have integration along the x-axis. It's going to integrate from A to B, f of x dx. Well, I can also graph and have a curve going this way, and I'm going to go right to left, and I'm going to integrate from C to D. Okay, so I'm going to integrate C to D, and they're f of y dy, just like you did area with respect to the y-axis. All right. Okay, we talked about that. Semicircle. The area formula for a semicircle is 1/2 pi r squared. I'm going to go back to x-axis because my brain works better that way, and it's a good way to learn. So here we are. This, and there's a semicircle coming out of the paper. So this distance B is the diameter. So I'm going to replace R with B over 2 squared, because half of this distance is going to be the radius of my circle. Well, if I square that, you get 1/2 pi B squared over 4. So it simplifies to pi over 8 times B squared. Equilateral right triangle. Remember, those go like this. They're 60 degrees. So this is the 30, 60, 90 triangle. If this is B, this side is 1/2 of B. This side is going to be B, and this is going to be root 3 over 2B. So on half the base times the height, so you have 1/2 of B times the height, which is root 3 over 2B, and you end up with root 3 over 4B squared. Okay, an isosceles right triangle, what they're talking about is this side and this side are B, and here's your hypotenuse. So it's just 1/2 of B squared. The last one here says an isosceles triangle with the hypotenuse side. So instead of my triangle like this, it's this way, and these two are the same length. So if this is b over root 2, and this is b over root 2, because it's isosceles. Well, if you do the Pythagorean theorem, this is 1/2 of b, so you have b over 2 squared plus the height squared equals b over root 2 squared. So b squared over 4 plus h squared equals b squared over 2. If I subtract b squared over 4, I get b squared over 2, right? This is 2 over 4. I get, b squared over 4. So h is equal to b squared over 4. H squared is. So h is equal to b over 2. Oh, that was complicated, wasn't it? So now the area of my triangle is 1/2 the base times the height. The height, what did we say, was b over 2. And you get 1/4 b squared. All right, those are the formulas that are tricky. Those are the basic shapes coming out of the side of the paper. All right, so now let's actually do some calculations. All righty, so find the volume of a solid whose base is bounded by x squared and 4x minus x squared, and which the cross sections are perpendicular to the x-axis and are squares or semicircles, etc. Okay, so I usually make myself a quick sketch. Let's do blue. All right, this is x squared. This is a parabola. Its roots are what? 4. Let's see, you take x out of it and you get x minus 4 minus x, so it's at 4 and 0. So it's opening down. So here's the section I'm worried about. So I have to find the intersections. All right, so the intersection is set 4x minus x squared equal to x squared. You get 4x plus, minus, 4x minus 2x, dang it, 2x squared equals 0. You pull out 2x and you're left with 2 minus x. So I got x equals 0 and x equals 2. So those are my bounds. So I'm going to integrate from 0 to 2. And I'm going to erase my calculation here. All right. Now, they tell me they're squares. So the distance between them is the base. So you have to figure out which one's on top. The one on top is 4x minus x squared. Dang it. Let me fix that. There you go, x squared minus the one on the bottom. And that's the base. And my formula up here tells me it's base squared. So I square it, then dx. And then you can just go put that in your calculator, or you can do it by hand. You have to do both, but for the sake of this video, I just put them in my calculator. And that's the answer. Okay? Remember, if you're going to do it by hand, you have to FOIL this. Don't forget the square up here. All right, common mistake. All right, so if I do semicircles, we already know the intersection, so it's going to go from 0 to 2 again. We know the base is 4x minus x squared minus x squared. For a semicircle, we said it's pi over 8 times b squared. Well, the pi over 8 can hang out here. You know, if you want to clean it up, you got 0 to 2, and you get 4x minus 2x squared, and then you're going to square it. You can do that. And again, I put it in my calculator and got 1.6, I think that's 75. Okay. Now remember, this is the same two equations. We did squares, semicircles, isosceles right triangle. Isosceles right triangle, what's the formula? 1/2. So you got a 1/2 hanging out front. Same integral. So let's keep them combined. So 4x minus 2x squared. And I got 2.133. You'll notice the areas are all different because the shape coming out is different. We had a square, we had a semicircle, equilateral right triangles. What's my formula tell me? Root 3 over 4. So root 3 over 4, same integration. Don't forget that square, guys. And when you do it by hand, remember to square them. So this is 1.8475. Not bad. Okay, so you're going to find intersection points. You set them equal to each other. Determine what formula you need, and then evaluate. All right, does this one, oh, this is to the x-axis. This one's to the y, so that's good. All right, different problem. Find the volume of a solid whose base is the region bounded by the graphs of square root of x and x squared over 8. Well, let's see, x squared over 8 is pretty flat, right? So it's going like this. And the square root of x is going like this. So I need those two intersections. X squared over 8 equals the square root of x. I squared both sides and got x to the 4th over 64 equals x. And then I had x to the 4th over 64 minus x equals 0. You pull out an x, you get x cubed over 64 minus 1. And so you end up with x is equal to 0 and x is equal to 4. Okay, well, there's my algebra. You can always stop it if you didn't quite get it. Oh, sorry, wrong one. There we go. There. All right, so we know this one's on top. We know we're going to integrate. Oh, we're going to integrate from 0 to 4. Square root of x is on top. X squared over 8 is on the bottom. That's squared, and it's going to be a square, so that's all you have to do. Okay? And when you calculate it, you get 2.057. This one's a little bit different. It says the base of the triangle enclosed by x plus y equals 4, the x-axis and the y-axis. So here we are. It's here, or it's here, here, and that would be the same as y equals negative x plus 4. So it goes this way. So that's 4 and that's 4. So that's the base, okay? Oh, it says to the y-axis. So first I have to solve this for x instead. Okay, x equals 4 minus y. So remember, if you're going to integrate against the, it's always right minus left instead of top minus bottom. So we're going to integrate from 0 to 4, right minus left, dy. So we integrate 0 to 4. The right is the line. So that's 4 minus y. And the left is 0, so we don't need that. You square it. Semicircles, you put pi over 8 outside. And this is with respect to y. Okay? Key thing here, solve your equation for x. X equals when you're going against the y-axis. Okay? I did the math. Actually, I did this one by hand and get 8 pi over 3. Because you can FOIL this. You get 16 minus 8y plus y squared dy. And you know how to integrate that. Okay? All right. Find the volume of the solid whose base is bounded by the graphs of. The cross sections are perpendicular to the y-axis. Ooh, I think I did this one wrong. No, I didn't. I fixed it. All right. So how's it go? It goes like this. It goes like this. Y equals 0 and x equals 1. So this is the area. And they want to do it to the y-axis, so I have to solve for x. I need to know that intersection point. Well, where is x cubed equal 1? That's at 1. So I integrate from 0 to 1. Right minus left. So right is the line. Left is the cube root function. You square it. And what are we saying they are? Equilateral triangles. So you multiply by root 3 over 4. Okay. Remember, right minus left. Right minus left. You got 0.0433. Okay, base in xy plane is bounded by 4 minus y squared and x equals 0. Find the volume perpendicular to the x-axis. So they're being mean to us again. Well, I'm going to graph it the way it is because it makes sense to me. It goes like this. It's a parabola on its side. It opens to the left, and x equals 0. So you're here. And I think their answer's wrong because it doesn't say only above the x-axis. So you've got to integrate from 0 to 2. I mean, negative 2 to 2. And I think their answer is only from 0 to 2. Semicircles, and the diameters are on the base. Okay, so semicircles. So right minus left. Oh, we're going to the x-axis. Oh, there's the problem. If you're going to the x-axis, you'd have to do this twice. Oh, that's where my mistake is, because you're going to integrate to here. Oh, see, you got to be on your toes. I graphed it that way, but I have to solve this. You get y squared equals 4 minus x, so y is equal to the square root of 4 minus x. And that's only the positive root in this case. So you're going from 0 to 4, because that's the point right there. And then it's top minus bottom, so the square root of 4 minus x, the bottom is 0. And then you square it. What are we doing? Semicircle. So pi over 8 dx. And that answer is 3.14. Or pi. Okay. Last one. Enclosed by e to the negative x. The coordinate axis, the line x equals 3. So I graphed this baby. E to the x goes this way. E to the negative x. Y equals 3 is here. And it says the axis, so it's here and here. It's that area. It's perpendicular to x-axis. They're squares, so all I need is this distance. So it's top minus bottom. So I have e to the negative x minus 0, and I integrate from 0 to 3 because that's where that line is. And I'm going to square it. So then I actually did this one because they gave me an answer, so I have to figure this out. 0 to 3. So you get e to the negative 2x dx. Then I let u equal negative 2x, and du is equal to negative 2 dx. So you end up with a negative 1/2 out in front. 0 to 3, e to the u du. The integration of e to the u is e to the u from 0 to 3, and I'm going to multiply it by a negative 1/2. So negative 1/2, e to the negative 6, e to the 0 is 1, and I multiply by a negative 1/2, so I end up with this. This is my answer choice when you simplify it. Good stuff, y'all. So what are you going to pay attention to? Am I perpendicular to the x or the y? If it's the x-axis, you need an equation with y equals. If it's to the y-axis, you need an x equals. Make sure you remember to square things. Make sure you learn these formulas. We don't give those to you. You have to know those. So these right here commit to memory. All right. And then you'll be okay. Happy practicing.